thank you, Mark, for the introduction, but also thank you, Mark and IFPRI for organizing this special event for AgMIP to really share with the IFPRI community and the Washington, D.C. community and those online the exciting new work that AgMIP is organizing on global and regional assessments of climate change impacts on agriculture and food security. So the marching orders, I think, very much have come from COP21 in Paris, in which, in the agreement, the delegates who agreed on action on climate change, recognizing the fundamental priority of safeguarding food security and ending hunger, and the particular vulnerabilities of food production systems to the adverse impacts of climate change. So we in the research community have our marching orders. We have to significantly improve our understanding so that we can develop resilient agricultural systems as we march into the future. Mark gave the mission statement to provide effective science-based agricultural decision-making models and assessments of climate variability and change and sustainable farming systems to achieve local to global food security. And that cross-scale analysis is one of the hallmarks of the AgMIP approach. AgMIP, and Jim Jones is here, who is also one of the co-founders of AgMIP. And Jim likes to say that AgMIP is a worldwide science community. And just to prove it, here are some of the pictures of the global and regional workshops that we've had over the years since AgMIP was founded in 2010. Now, it's not just the individual researchers and scientists who are part of AgMIP, it's also the partnerships. So this is a new way of doing science. It's a kind of a science networking. It's like sort of like social networking, because it's the researchers who come together and their institutions come together to do multi-model research and assessments. That's how we get the significant improvements going forward. So this is the science approach for phase 2, which we're now planning the next 5 years for AgMIP. First in the, let's see, can we see it? Yes, right in the center, agricultural system models. It's crops and livestock, economics, pests and diseases, and water. We have water group, soil carbon group. All of the elements that are needed to really understand impacts of climate extremes and change there are groups in AgMIP which form to do critical multi-model research to actually improve the models. So that's at the models themselves are at the heart. But we utilize the models in 2 ways. Track 1 is to develop and test the next generation of agricultural systems models. If we just keep using the same old models, we're not going to be able to do a better job. So that's why we of course, historical conditions, the model calibration and improvement, evaluation and intercomparison. Huge numbers of modelers around the world are engaged in track 1 work. But then, if we're just constantly improving the models and not doing assessments with them, what are we really learning? So track 2 is to conduct multi-model assessments for sustainable farming systems and climate responsive agriculture. And this little triangle right at the bottom is a part also that Jim works very, very hard on, which is the data and the data harmonization. So because models need data, and we would also submit that data need models to actually get organized and be useful. So there's a big part of AgMIP which is engaged in data as well. We are now, for the second phase of AgMIP, bringing all of the people and the partners to bear on 3 focus areas. One is modeling. Let's start with the soil at the bottom. That's why it's brown. The next generation of knowledge products, improved models, and data. But with those, we're looking in particular for modeling for sustainable farming systems, all the development issues that are needed, particularly for smallholder farming systems. And then the part on the right, which is what we're talking about primarily today, is the coordinated global and regional agricultural assessments. So what is actually going on with this? And this slide encapsulates basically the building blocks that the first 5 years of AgMIP have created so that we can go forward to actually coordinate across global and regional scales and across the disciplines. So we have regional research on farming systems, and John's going to talk more about this and show some results of this, linking both biophysical and socioeconomic models. We have production systems also at the regional scale. This is the linkage, the biophysical and the socioeconomic. So this is the regional axis. On the global scale, we have teams of global gridded and livestock modelers and models. For example, on the global gridded side, we're now up to about 10 to 15 global gridded models. So you can see that while we look deeply at the sites and regions with more site-based or small sites and regions, but then we can use the global gridded to fill in, aggregate, etc. And then, of course, here, as the home of the leadership of the global economics team, with analysis of the world and regional prices, because if we don't have, since agriculture, as we all know, is both a regional system and a global system, we have to be able to create the linkages between the two. So these regional economic models utilize global prices, the prices from the global models as part of the linkages. I'm just going to briefly show some results from some of the work that goes into those building blocks. So the first thing is that these are the results from 27 wheat models. We thought there were going to be 5 to 10 come out of the woodwork. 27 came out, even now more. And we do an ensemble approach. And these are showing 4 places around the world, from the Netherlands, Argentina, India, and Australia. And what we do with these are tested with field data at sites with the ensemble of models. So what we found from using the ensembles is that the ensemble of models predicted the yields accurately. These lines here are the medians. And when you compare all of those to the X's of the observations, they did a very good job. Most individual models could not predict across all the sites. So what this is really showing is, as what we've also seen in climate modeling, that the multi-model approach is very effective. And what's also interesting is that this result is true under both poorly and well-calibrated conditions. That speaks to being able to utilize the models in areas that are data sparse as well as those that are data rich. So this is the work that we've been doing with the individual crops and site-based models. But then we utilize these in teams of regional integrated modelers and regional integrated assessments that are really bringing together both the biophysical and the climate. And we have Alex Vervain here, who is the head of the climate group at AgMIP and also science coordinator. So it's transdisciplinary across climate, biophysical, and socioeconomic. It's a farming system approach beyond the crop modeling that had been done for a long time, multi-scale, as we spoke about, and multiple models. So we get this power of the ensemble. And as John is going to show, with this approach, we're now, with the AgMIP approach, we're now really able to look at distributional results, including impacts on poverty. Now, to give just one example from the global gridded crop models that I mentioned, this is, at the end of the century, climate impact median of 7 global gridded crop models and 5 GCMs. And remember, these are the biophysical results, not the economic results. That's why you see, for example, some increases in areas that probably, when we test in the economic models, won't have a lot of big production in some of those regions. But what we find here is, and we're very, very pleased, it's a little bit hard to see, but there are actual hatch marks showing where the models agree. This is the very first time, just like in the IPCC for the climate regions, this is the very first time in this work that shows that across a range of models. So the results then are more robust, showing the lower latitudes are more vulnerable to climate change. We still are working very hard with experimentalists on this direct physiological effects of carbon dioxide. And in fact, the AgMIP crop team, led by Delphine Daring, has a new paper in Nature Climate Change that's just coming out. I think it's next week or maybe posted now on the CO2 effects. This is still one of the very key issues that we have to resolve on the biophysical side. And then we also then look at the interactions, of course, with things like nitrogen fertilization. So this is what the global gridded crop team is bringing to bear on the global and regional assessment. Now I'm going to show one result from The Economist. I'm not an economist, I'm trained as an agronomist. And so Keith is going to be saying much more about the global economic model intercomparison. But this is showing with 10 global economic models, 2 GCMs, and 2 different crop models. Across here are all the ones that you probably recognize the names of from, of course, impact is here. But it's showing the effects on prices of climate change on agricultural prices. This is in the 2050s relative to results without climate change in 2050. So what we see is upward pressure on the prices, although with really a wide range of results coming from the models. So I know that that's what the global economics team is working on very hard to understand what's causing that wide range of uncertainty. And so this idea of this part of understanding from each one of the disciplines, which is contributing the uncertainty and what types of uncertainty that is coming from the global economics modeling, from the global crop modeling, and then from the climate itself. So this AgMIP approach is really working to be able to understand and really define and characterize that uncertainty cascade, as well as the robust results that we then can share in a much more robust way to decision makers. So this is my final slide before turning over to John Antle. And this is the work, this is the framework diagram for the coordinated global and regional assessment and the core risk and resilience framework. So what we have in the middle is we have core scenario sets focusing on extreme events and shocks. We're not only going to look at future climate, we're going to look at near-term climate as well. And of course, we have to look at, especially with the SDGs passed in last September, we have to look at sustainable development as well. We look at the global to regional scaling. We look at risk and resilience, and also continuing to do the basic science work on diagnostics and uncertainty. But across these then core sets, there are 2 axes. One is the responses to climate change, adaptation and mitigation, designing scenarios that will test things like genetics, resource management on the adaptation side. For example, biofuels, soil carbon and nitrogen on the mitigation side. The other axis, the horizontal axis, is from food security to food policy. Here, and this is a very exciting new area for AgMIP, we have nutrition scientists with us who are in the design of the CGRA to bring in diet standards, for example, going beyond calories. And of course, land use change on food security, on food policy, import, exports, and subsidies. So with that, this is the major framing that we're going to be utilizing for bringing in both the global modelers as well as regional modelers, regional integrated assessment modelers across the world as we work on really moving for the first time, and we hope to finish the results, to be sure to have them be part of the IPCC fifth assessment, but also to contribute very much to the SDGs, the implementation of them, and the development of adaptation and resilience, as well as mitigation policies. And with that, I'm turning over to John Ansel. Thank you very much.